Yes, yeah, best believe. Explore and learn new things.
The universe is a vast and mysterious place that contains everything that exists, from the smallest atoms to the largest galaxy. It's estimated that the universe is about 15 billion years old, and it's constantly expanding and changing. In this lesson, you will learn about some of the fascinating features and phenomena of the universe, such as stars, planets, black holes, dark matter and dark energy, and the Big Bang theory. We will also explore some of the tools and methods that astronomers use to study the universe, such as telescopes, satellites, probes, and mathematical models. By the end of the session, you will have a better understanding of the origin, structure, and evolution of the universe and its components. We will start the lesson by discussing the universe, then we'll discuss the formation of the universe, and we will finish by the formation of the solar system. So the universe is the vast, extended space that contains all the galaxies, stars, planets, moons, living organisms, and everything. And it was estimated that the universe contains about 100,000 million or 100 billion galaxies. And the galaxies, as you look at this photo, as we zoom in, each dot in the photo represents a galaxy. So we have a numerous amount of galaxies in the universe. And the galaxy are a group of stars that rotate together by the effect of gravity. And they are the greatest unit in the universe. And each galaxy, as you see, has a distinctive shape due to the harmony and order of stars that rotate together. Sometimes group of galaxies rotate together due to the effect of gravity. We call them galaxy clusters. So the galaxy clusters are a group of galaxies rotate together by the effect of gravity. And the galaxy in which our solar system belongs to is called the Milky Way galaxy, and it's spiral in shape. So the Milky Way galaxy has a spiral shape. The way we call it a Milky Way galaxy is because it's appears in the sky as a splashing milk or spreading straw. And the Milky Way galaxy contains all the stars we can see in the night. In any galaxy, including the Milky Way galaxy, the oldest star rotating near to the center of the galaxy, and the younger stars rotate in the outer portion of the galaxy. And because our sun, considered as a young star, it exists in one of the spiral arms of the Milky Way galaxy. And it contains the sun and the 8 planets that are revolving around it. And the solar system exists in one of the spiral arms of the Milky Way galaxy, and the sun takes about 220 million years to form a one revolve around the center of the galaxy. Force of gravity is responsible for keeping the planets in their orbits around the sun, and as the distance between the sun and the planet increase, the gravity decrease, and then the planet became slower. The distance between celestial bodies, such as stars, are very large and very huge. We can't measure them in kilometers, so we use a light year. So we use the light year as the measuring unit between the celestial bodies. And the light year is the distance covered by light in 1 year, and equals 9.46 multiplied 10 to the power 12 kilometers. And the distance between galaxies are not fixed. They keep increasing as time passes because the galaxies are moving away from each other. And we call this phenomena the expansion of the universe. So the expansion of the universe is the continuous separation between galaxies in space because of the regular movement. And if we get a balloon and you draw some dots and you start inflating, you will see that as you inflate the balloon, the distance between the dots increasing as time passes. So we use this to represent the expansion of the universe as the follow. So the swelling of the balloon represents the expansion of the universe, The separation of the dot express the separation of the galaxies from each other, and the increasing the distance between dots represent the continuous expansion of the universe. So how the universe was formed? Many scientists believe that the universe emerged from a massive explosion called the Big Bang, but it's not an actual explosion. Explosion here is just an expression, and we call this explosion Big Bang. And what supported the theory of the Big Bang is this photo, which is called the cosmic microwave background. And the story goes by there was a team led by George Gamow, was the first people or first scientists to predict that due to the Big Bang there will be a source of cosmic radiation coming from all directions in the universe. So Robert Wilson and Enro Benzies was working in 1960 for the Bell Labs, which was one of the first labs that have an antenna capable of detecting the microwave radiation. And they were working to calibrate and eliminating noise. So they were getting a noise from all directions at all times. And they didn't know what was the source of this noise or interference. But they published the research in the Astrophysics Journal in 1960. And in the same year, the scientist Robert Dicke was trying to build an antenna to detecting the cosmic radiation, the cosmic microwave radiation. And when he read the paper by Enro Benzies, he became sure that this radiation, what he was looking for, the cosmic microwave background. So the Big Bang is the theory that explains the origin of the universe from a massive explosion since 15,000 million or 15 billion years, and resulted in all the forms of matter, energy, time, and space, followed by continuous expansions and changing process. So the Big Bang starts with the Big Bang, in which the gaseous ball, which was the universe originated, exploded, and the process of expansion and changing started. Then, when the temperature became 10,000 million degrees, it was cool enough to form the atoms. And the first atoms to form was hydrogen and helium. The hydrogen was 75% and helium 25%. So after about 1,000 million years, the atoms clumped together in forming the matter. Then, after about 2,000 to 3,000 million years, the gravity helped in gathering more masses, forming the ancestral galaxies. After 3,000 million years, the galaxies start to form. After about 5,000 million years, our galaxy, the Milky Way, start forming. And then after about 10,000 million years, the Sun was born and the Earth planet created after that. After about 12,000 million years, the earliest life form began to appear on Earth. And finally, after about 15,000 million years, the universe as it is now.
The universe is everything. From the tiniest particles, to the largest galaxies, to the very existence of space, time, and life. But how did it all begin? The origin of the universe is the origin of everything. Multiple scientific theories, plus creation myths from around the world, have tried to explain its mysterious genesis. However, the most widely accepted explanation is the Big Bang Theory. The Big Bang Theory states that the universe began as a hot and infinitely dense point. Only a few millimeters wide, it was similar to a supercharged black hole. About 13.7 billion years ago, this tiny singularity violently exploded. And it is from this explosion, this bang, that all matter, energy, space, and time were created. What happened next were two major stages of the universe's evolution. Called the radiation and matter eras, they're defined by key events that helped shape the universe. First came the radiation era, named for the dominance of radiation right after the Big Bang. This era is made of smaller stages, called epochs, that occurred within the universe's first tens of thousands of years. The earliest is the Planck epoch. No matter existed in the universe at this time, only energy and the ancestor to the four forces of nature, the superforce. At the end of this stage, however, a key event occurred in which gravity split away from the superforce. Next came the Grand Unification epoch, named for the three remaining unified forces of nature. This epoch ended when one of those forces, called strong or strong nuclear, broke away. Then, the inflationary epoch began, during which the universe rapidly expanded. Almost instantly, it grew from the size of an atom to the size of a grapefruit. The universe at this time was piping hot, and it churned with electrons, quarks, and other particles. Then came the electroweak epoch, when the last two forces, electromagnetic and weak, finally split off. During the next stage, the quark epoch, all of the universe's ingredients were present. However, the universe was still too hot and dense for subatomic particles to form. Then, in the Hadron epoch, the universe cooled down enough for quarks to bind together and form protons and neutrons. In the lepton and nuclear epochs, the radiation era's last two stages, the protons and neutrons underwent a significant change. They fused and created nuclei, and in doing so, they created the first chemical element in the universe, helium. The universe's new ability to form elements, the building blocks of matter, cued the matter era. Much as the name suggests, the matter era is defined by the presence and predominance of matter in the universe. It features three epochs that span billions of years, the vast majority of the universe's lifespan, and includes the present day. The first was the atomic epoch. In this stage, the universe's temperature cooled down enough for electrons to attach to nuclei for the first time. Called recombination, this process helped create the universe's second element, hydrogen. This hydrogen, along with helium atoms, dotted the universe with atomic clouds. Within the clouds, small pockets of gas may have had enough gravity to cause atoms to collect. These clusters of atoms, formed during the galactic epoch, became the seedlings of galaxies. Nestled inside those galaxies, stars began to form, and in doing so, they cued the latest and current stage of the universe's development, the stellar epoch. The formation of stars then caused a tremendous ripple effect and helped shape the universe as we know it. Heat within the stars caused the conversion of helium and hydrogen into almost all the remaining elements in the universe. In turn, those elements became the building blocks for planets, moons, life, everything we see today. This ecosystem of everything was only possible because of the many stages in the universe's development. While countless questions about the origins of our universe remain, it's only a matter of time for some long-sought answers to emerge.
So, the formation of the solar system. There are many scientific and philosophical theories about the evolution of the solar system, and these theories are still approved and subject to change, because the word theory means an approved scientific statement, but it can be changed and modified based on the new information. And the theory that we will discuss are the nebular theory by Laplace in 1796, the crossing star theory by Chamberlain and Moulton in 1905, and the modern theory by Fred Hoyle in 1944. So the nebular theory, Laplace based his theory on two observations, which are: there is something that looks like a cloud or nebula in space, and the space contains many cloud rings surrounding some planets, such as the rings of Saturn. So the nebula is a glowing gaseous sphere revolving around itself, from which the solar system was originated, and the nebula representing the nursery of forming new stars. And there are many nebula, such as the Crab Nebula, the Puppet Nebula, and the Butterfly Nebula. And the theory goes by that the solar system originated from a glowing gaseous sphere revolving around itself. This sphere called nebula. And over the time, the nebula lost its heat, and the size contracted, and the revolving speed increased. The centrifugal force arising from the rotation of nebula around its axis led to, first, the nebula lost its spherical shape and became a rotating disk, and led to separation of part of the nebula cloud, but they remain revolving around the central hot mass. The gaseous ring cooled down and frozen, forming the planets, while the flaming mass in the center formed the sun. Then the crossing star theory by Chamberlain and Moulton in 1905. There was another huge crossing star approaching the sun. The star attracted the sun, leading to the great expansion of the part of the sun facing it. So because the huge star approaching the sun, by the gravity of the huge star, it's pulled some of the gases from the sun. The expanded part from the sun, leading to the sun, escaped the gravity of the star, and a gaseous line was formed of a great length from the sun until the last planet, which will be formed later. The gaseous lines start to condense due to the attraction force and cool down, forming the planets. Finally, the modern theory by Fred Hoyle in 1944. And Fred Hoyle built his theory on the origin of the solar system based on a known astronomical phenomena known as star explosion. And the star explosion, it's sometimes the star gets more nuclear activity and it just explodes, increasing the shining of the star and expelling some of its gases. So the star explosion phenomena, glowing of a star for a short time, become one of the most shining stars in the sky, then glowing disappears and returns to its original state. So the way that happens is sudden violent nuclear reaction occurs within the stars. lead to the explosion. The star pumps huge amount of gaseous materials because of its explosion, leading to the increasing in size and shining. When the pumped gas are cooled, the shining of stars return to its original state. So here is an example of an explosion star. So the star was rotating near the sun. This star explodes due to the huge amount of nuclear reactions, and due to the explosion, the star escaped from the sun gravity, and the explosion bent a huge amount of gas toward the sun. The gaseous cloud are cooled, forming the planets, and the sun controlled the orbit of the planets around it. And the important instrument we use to study the outer space are the Solar Telescope, the Hubble Telescope, which launched in April 1990, and it's rotating around the Earth at a height of 500 kilometers. And the newest instrument will launch in space was, I believe, 2 years ago, called James Webb Space Telescope.